Hello student, welcome in CHIM College, Nasik. Student, in previous lecture we have seen substitution in octahedral complexes, and in previous lecture we have finished that topic also. In today's lecture we will discuss substitution in square planar complexes. In substitution in square planar complexes we have to see whole trans effect, means trans effect, theories of trans effect, different kinds of examples of trans effect and its application. So let's see one by one. So student, first of all let's see learning objectives of substitution in square planar complexes. First of all, we have to see trans effect, means what is meant by exact trans effect. After that, we have to see trans series. Trans series is for different types of ligands. After that, we have to cover theories of trans effect. Basically, there are two main theories of trans effect. First is polarization theory and second one is pi bonding theory. After that, we have to see different examples based on trans effect or based on polarization power or trans bonding power of ligands. After that, last is applications of trans effect. These are the learning objectives for substitution in square planar complexes. Okay. This chapter is very simple. We have to see trans effect, trans series, theories of trans effect, different examples of trans effect and applications of trans effect. Okay student, so let's see what is meant by trans effect. Trans effect may be defined as labilization of ligand trans to certain other ligand. What is trans effect? Labilization of ligand trans to certain other ligand, which can thus be regarded as a trans-directing ligand. It's just a labilization of ligand trans to certain other ligand. First of all, what is meant by labile ligand? Labile ligand means which easily exchange. That ligand is easily exchangeable. That is nothing but labile. So, the trans effect may be defined as labilization of ligand trans to certain other ligand. Only consider trans position. Okay. So, also trans effect is also defined as the ability of an attached group to direct a substitution into the position opposite to itself. It's called as a trans effect. Got it student? What is meant by trans effect? It's a very simple concept. Labilization of ligand trans to certain other ligands, or the ability of an attached group to direct substitution into the position opposite to itself. It's called as trans effect. Student, whenever we will see the theories and examples, you will be clear about trans effect. It is also called as kinetic trans effect. The trans effect is also called as kinetic trans effect. And the trans effect is a particular feature of ligand displacement in square planar complexes. So, the trans effect is only related with square planar complexes, means this effect always observed in square planar complexes. And the trans effect is a particular feature of ligand displacement in square planar complexes. Have you understood what is meant by trans effect? It's a very simple concept. Only go through the opposite position ligand. Okay, so the trans effect may be defined as labilization of ligand trans to certain other ligand. Okay, and this effect always observed in square planar complexes, and trans effect is a particular feature of ligand displacement in square planar complexes. Only remember that if you have to study trans effect, only think about square planar complex. Okay, don't think about octahedral and any other else. So only think about square planar complexes. Okay, student. So let's see the trans-directing series, means how the trans-directing series is set up. Okay, so the trans-directing series can be set up by comparing a large number of reaction rates. Means by studying large number of reaction rates, the trans-directing series can be set up. The reaction employed by Langford and Gray to compare the trans influence of L and L. L and L are nothing but ligands. So the reactions employed by Langford and Gray to compare the trans influence of L and L. This is the general reaction, that how to set up that trans-directing series. See, this is L, this is also L. These both are the ligands. These are also ligands, X and X. When Y is attack on this square planar complex, then there is replacement of one X opposite to this L. Consider opposite position of this L. Y is situated the X, this X position opposite to this L, which gives product. This is nothing but trans effect. This is the trans effect of L. This is the trans effect of L. This is the trans directing series. What I have told about trans directing series, the trans directing series can be set up by comparing a large number of reaction rates, and the reaction employed by Langford and Gray to compare the trans influence of L and L. This Y is situated at the position of this X, means this is the trans effect of this L ligand. So let's see the order of ligand for increasing trans effect. See, this is the order of ligands increasing trans effect. Carbonyl, CN, NO, C2H4. This is near about same power. Then which is greater than PR3H. This sign indicate near about same. Okay. This is the highest. This all ligands are the highest position at this series, and these are the at lowest position, means this shows less trans effect, while this shows higher trans effect in this series. Student, if you should if you have to study properly the trans effect, you should know this whole series, means you have to learn perfectly this series. Okay, see, CO, CN, NO, C2H4 all are the pi ligands. Okay, these all are the pi ligands. So we can say that the pi ligands are at the higher in series, higher position in series, while the sigma bonded ligands are at the lowest position. Okay, student. So this is the series for trans effect. Basically, there are two theories of trans effect. I have already told that there are two theories. First is polarization theory and second one is pi bond theory. Let's see one by one. Let's consider first is polarization theory. See, this is square planar complexes. Here is central metal atom, while these all are the ligands. This theory concerned with effect on ground state. This theory, always remember, this theory concerned with effect on ground state. When the complex contain ligand in which one of the ligand is more polarizable. If we are studying polarization theory, so remember polarization word. When the complex contain ligand in which one of the ligand is more polarizable than another one, then the dipole induced on the central metal ion. Then the dipole induced on the central metal ion which reserves the electron density, and is distorted via sigma bond towards the transposition. See what happened here. This is the central metal atom. Only consider Y and X. Don't think about this both X. Okay. So what theory tells that if one ligand is more polarizable than other, so let's consider Y ligand is more polarizable than X. What happened at this situation? If Y is more polarizable than X, then the dipole induced on the central metal atom. What happened? Dipole induced on the central metal atom which reserves the electron density, and is distorted via sigma bonding towards the transposition, means towards the mx, okay, towards the mx. So the mx bond becomes weak and lengthen, means length of mx bond becomes increases and it becomes weak, so the x can easily replace with another ligand. Okay student, what is polarization theory? In polarization theory, if one ligand is more polarizable than another ligand, then at this stage dipole induced on the central metal atom which reserves the electron density and is distorted via sigma bond towards the transposition. The X is opposite to Y ligand. X ligand is opposite to Y. So if Y is more polarizable, dipole induced on the central metal atom and which reserves the electron density and is distorted via sigma bond towards this opposite position, means towards this mx. So the mx bond becomes lengthened and it becomes very weak, so it can be easily replaceable and another ligand can be fixed at this position. This was about polarization theory. Okay, I think this polarization theory is simplest. So student, let's consider next theory, that is pi bonding theory. In pi bonding theory, it deals only with pi bonding ligands. Obviously, though it is pi bonding theory, it deals with pi bonding ligand. It explains the trans effect in a group such as CO, Cn-, C2H4, thiourea, PR3 in terms of their ability to form pi bond, and suggests that these are high in the trans effect series because they tend to stabilize the transition state for reaction. Okay student, so let's consider this complex is square planar complex where L is a pi acid. Okay, L is pi acid. The ligand X is situated trans to L. L is pi acid. This X is ligand which is situated trans to L. The transition state, this trigonal bipyramidal geometry is nothing but the transition state. The transition state in this reaction to have a trigonal bipyramidal geometry. Okay, after movement of y and x. The trigonal bipyramidal transition state can be stabilized. This trigonal bipyramidal transition state can be stabilized in empty pi orbital, means p orbital, d orbital or pi star orbital of ligand. What I have told? The trigonal bipyramidal transition state can be stabilized in empty pi orbital, means p orbital, d orbital or pi star orbital of ligand L overlap with non-bonding filled orbital of the metal M to form pi bond. Here is overlapping between empty orbital of ligand and filled orbital of metal to form pi bond. But during this pi bonding formation, the electron density from dxz is withdrawn away by this nucleophile Y. What happened during this interaction, means during this overlapping, the electron density from dxz orbital withdrawn away by this incoming nucleophile or incoming ligand Y. And obviously because of this, mx bond becomes lengthened and becomes weak, so it easily get removed, and instead of x y is situated at this position, means trans to L or trans to Y. Okay student, this was about pi bonding theory. Have you understood the pi bonding theory? What happened here? Whenever this is a square planar complex, whenever Y attack on central metal atom, there is movement of Y and X. During this reaction, there is formation of trigonal bipyramidal transition state. Okay, whenever we get this trigonal bipyramidal transition state, there is overlapping between the empty p orbital, pi orbital, d orbital, sorry, the p orbital, d orbital or pi star orbital of the ligand with filled orbital of metal. During this interaction, there is electron density from this dxz orbital withdrawn away by Y, that is incoming nucleophile Y, and obviously because of this mx bond becomes lengthened and weak, and the x get easily removed, and instead of this x the Y is situated at this position. Okay student, so this was about today's lecture, that is trans effect. After that we have seen trans effect, series of trans effect and theories of trans effect. There are two theories, polarization theory and pi bonding theory. Okay student, in next lecture we will discuss the examples of trans effect. Okay, thank you.